Most of us have heard that nothing in the cosmos can surpass the speed of light, that it's the universal maximum velocity. What's often missed, however, what doesn't truly sink in, is the profound significance of that cosmic speed cap. This isn't some arbitrary regulation. It wasn't decided by a cosmic committee. Instead, this limit emerges from something far more fundamental. It is woven into the essential nature of space-time itself. And the consequence of nearing that velocity is a phenomenon that sounds like pure speculation, but is demonstrably true. It will serve as the foundation for grasping why our theoretical extraterrestrials are confined. Let me break this down in a way that clicks. Picture a flawless timekeeping device, not one on your wrist, but one that operates by reflecting a beam of light between two mirrors. The light travels out, hits a mirror, and returns. Each time it completes a round trip, the clock registers one tick. That tick represents our fundamental measure of time. Got it? It's straightforward. Now, imagine we both possess one of these identical clocks, but we place ourselves in a specific scenario. You remain still while I am aboard a starship traveling at an immense velocity. Let's imagine I'm cruising at a substantial percentage of light speed, say 90%. How do you suppose my clock behaves? From where you're standing, this is what you would see. Because my clock is in motion, the beam of light inside it must travel out and back while the entire apparatus is hurtling through space. From your point of view, the light has to cover a greater diagonal distance since I'm moving. That journey for the light takes longer. Consequently, you perceive my clock as ticking at a slower pace than your own. My time is passing more slowly. Now, from my vantage point on the ship, everything feels perfectly ordinary. I have no sensation of moving in slow motion. My clock seems to be ticking away at its standard rhythm for me. Yet you, observing my clock from afar, see it ticking demonstrably slower. This is no trick of the eye. It isn't a malfunction of the clock. It's a genuine phenomenon. It's an intrinsic quality of time itself. The passage of time literally slows down for an object in motion relative to an observer. And the closer you get to light speed, the more dramatic this effect becomes. We can detect this. In fact, it has been detected. Back in 1971, two scientists, Hafley and Keating, placed atomic clocks on commercial jets flying in opposite directions around the globe. The clocks that traveled on the planes genuinely experienced slightly less time than the reference clock that remained stationary on the ground. We are dealing with microseconds, incredibly small fractions of a second. But the effect was undeniable. Time was literally passing more slowly for the clocks in motion. The reason this isn't apparent in our day-to-day lives is that we never achieve the necessary speeds. You could be speeding down a highway at 100 miles an hour, and your clock would remain perfectly synchronized with every other clock on the planet. The phenomenon only becomes significant when you're moving at a considerable fraction of the speed of light, and the speed of light is 186,000 miles per second. Just let that number settle in. 186,000 miles in a single second. We are currently incapable of constructing anything that moves that quickly. The most powerful rockets we possess today might reach speeds around 30,000 miles per hour. That is not even in the same ballpark. But let's consider what would occur if we could engineer a spacecraft capable of reaching 95% of light speed. At that velocity, let's propose a journey to a star system situated 10 light-years from us. From the perspective of someone on Earth, watching your departure, the voyage would last approximately 10 years. You would arrive, explore, and a decade would have elapsed back on Earth. But this is where things become truly strange. For you, on board that high-speed vessel, time itself is moving more sluggishly. Let me provide the specific figures. At 95% of the speed of light, your personal time progresses at roughly 1/3 the rate of time on Earth. So, while 10 years unfold for everyone on Earth, only about 3 years go by for you. You would have aged a mere 3 years while your counterparts on Earth grew 10 years older. Upon your return to Earth, you would still be young while everyone you once knew has aged considerably. If you had a twin sibling, they would now be 7 years your senior. This isn't a concept from a novel. It's known as the twin paradox, and it is perfectly accounted for by Einstein's theory of special relativity. It stands as one of the most counterintuitive yet absolutely real outcomes of living in a universe where time is not a constant. Time is relative. Its flow is dictated by your velocity. Now, this is where the implications become particularly fascinating and where we can begin to understand why extraterrestrial beings would find themselves trapped. Let me pose a scenario. If you departed from Earth on this starship moving at 95% of light speed and wished to send a communication back home to confirm your safe arrival, what would be the result? Well, light, by its very nature, moves at the speed of light. The transmission you send would require the same duration to return as your outbound journey took. You would get there after 10 years have passed on Earth, and your message would then take an additional 10 years to reach its destination. That's a 20-year total. You're attempting to interact with individuals who are now much older, people who might have moved on. You are utterly cut off. But hold on, the situation is even more problematic than that. Suppose Earth needed to transmit a navigational adjustment to you. They determine a few years into your voyage that you must alter your trajectory or that there was an error in the initial coordinates. They dispatch a signal at the speed of light, racing to overtake you. But you are already traveling at 95% of the speed of light. You are moving nearly as fast as the message they've sent. If they delay for too long, your velocity away from them will exceed the signal's ability to close the distance. From their viewpoint, they see your spacecraft receding, and their message simply cannot reach you anymore. It gets left behind. You have exited their sphere of influence. You are entirely on your own. That is the pivotal realization. That is the reason interstellar voyaging is so profoundly challenging. It's not an issue of engineering, not a matter of our inability to construct the necessary rockets, but a consequence of the universe itself. The fundamental principles of physics have arranged reality in such a way that if you desire to visit another star system within a human lifetime, you must move incredibly fast. And when you move that fast, time itself warps. Communication falters. You are severed from your origin. You essentially become imprisoned within your own temporal bubble. Let me make this more tangible, because I want you to fully comprehend what's at stake here. Our own galaxy, the Milky Way, spans roughly 100,000 light-years from one side to the other. Proxima Centauri, our nearest stellar neighbor, is a little over 4 light-years from us. The closest major galaxy, Andromeda, is 2 million light-years away. These distances are staggering. With our present level of technology, moving at any speed that even approaches a meaningful fraction of light speed is utterly out of reach. We lack the energy sources. We lack the propulsion methods. But let's imagine for a moment that we could invent such technology. Let's say we create some form of revolutionary propulsion, perhaps harnessing antimatter or something beyond our current imagination, and we manage to accelerate to, for example, 20% of the speed of light. That is still astoundingly fast, somewhere in the neighborhood of 40 billion miles per hour. At 20% of light speed, you could get to Proxima Centauri in about 20 years, from an Earth-based perspective. For the traveler on that ship, time dilation is less severe at this slower pace, but the effect is still present. You would age approximately 19 and a half years per every 20 years that tick by on Earth. So the impact is minor at these velocities, but it exists. But what if a civilization, the aliens we're discussing, were sophisticated enough to construct vessels that could attain 90%, 95%, or even 99% of light speed? Let's push the boundaries. Let's envision, for the sake of this thought experiment, the Arcturans. They inhabit a planet orbiting a star that is 36 light-years distant. They are exceptionally advanced. They make a decision. Let's travel to Earth. Let's pay a visit to that small blue world. They engineer a starship capable of moving at 99% of the speed of light. This is a speed and power level beyond our comprehension, but it is theoretically allowable. As per Einstein's calculations, at 99% of the speed of light, the effects of time dilation become radical. For each year that elapses on their home world, only around 2 months go by for the crew on the starship. The travelers aboard that vessel could complete the entire 36 light-year voyage to Earth while subjectively experiencing only about 6 years of travel. From an observer's perspective back home, 36 years have passed. Before the Arcturans on the ship, they have only gotten 6 years older. They show up here having journeyed through 3.5 decades of our history in what felt to them like a short trip. Now, here is the crucial point. Upon their arrival, they are incapable of sending a report back to Arcturan headquarters to say, "Mission accomplished." Because by the time the communication traverses the distance back to their home world, another 36 years will have passed. All told, more than 70 years will have elapsed on Arcturus since their departure. Every person they once knew would be gone. Their original mission parameters would be completely outdated. They cannot receive updated instructions. They cannot request additional resources. They cannot synchronize their actions with anything on their home planet. In a very tangible way, they are adrift and alone in the cosmos. They are confined to their own frame of reference, unable to sustain any sort of real-time link with their world of origin. And this brings us to the Fermi paradox. As you may know, the Fermi paradox poses the question, if the universe is so immense and contains so many stars, and if life should be statistically common, then where is everybody? The solution may very well be that the laws of physics themselves render it nearly impossible for interstellar societies to uphold any form of cohesive empire or network. Each civilization is, by necessity, isolated. Every probe launched into the void is a one-way trip, and when you truly consider the implications, that is a profound limitation. That is the universe declaring, no. You can have your home star system or you can venture to other star systems, but you cannot easily have both simultaneously. A choice must be made. Allow me to re-examine this from a different direction to ensure the point is clear. Let's assume intelligent life is widespread. Imagine that in our galaxy alone, there exist thousands of civilizations. They are all driven to explore, to expand, to establish contact. The obstacle, however, is this. The distances are so immense that even at relativistic velocity speeds nearing that of light, journeys to neighboring star systems require decades or even centuries. And if you travel fast enough to make the voyage seem brief for you, you have effectively marooned yourself from your home. You cannot return. You cannot sustain communication. You have essentially become a splinter faction of your own society, floating alone through the cosmos. Now I'm often asked, but what about wormholes? What about warp drives? What about exceeding the speed of light? I will concede that these concepts are mathematically viable within Einstein's general relativity. The equations do not forbid them. However, and this is a very significant however, they depend on forms of energy and matter that we have never detected and likely do not exist. A wormhole, for example, would necessitate something known as exotic matter, which has negative energy density, just to prevent it from collapsing. We've never found anything of the sort. A warp drive would demand the capacity to literally warp the fabric of space-time, creating a bubble where space compresses ahead of you and stretches out behind you. It's a captivating notion, but it would call for energy equivalent to the mass energy of the entire universe. It is not feasible. It is not something that can be engineered. So we are left with the universe as we find it, a reality dictated by Einstein's relativity, where the speed of light is the absolute maximum and time dilation is its unavoidable effect. These are not arbitrary regulations. They are not constraints placed on us by some unknown force. They are inherent to the very architecture of space-time. Let me present one final scenario that truly underscores the dilemma. Picture a civilization on a planet orbiting a star 50 light-years away. They are at least as technologically advanced as we are, perhaps far more so. They construct a probe, a robotic explorer, and dispatch it in our direction. They engineer it to travel at 50% of the speed of light. That is still remarkably fast, yet more plausible than 99%. The journey requires 100 years from our perspective on Earth. The robot reaches our solar system in, let's say, the year 2024. Now the creators of this probe endowed it with all the knowledge they possessed back in the year 2024. A full century of advancements in history has unfolded on their home world while the probe was in transit, but the probe is oblivious to all of it. They cannot provide it with new directives because any signal they transmit now will take another 50 years to get here. And the probe has already arrived. This robot is, in a way, an emissary from their past. It gets here and begins its exploration. It sends its findings back home, but there's a lag. It cannot engage in a real-time exchange. It cannot field questions from its home world and provide immediate answers. It is functioning with a 50-year round-trip communication lag. Every query from its home takes a century for a response. It is akin to attempting to hold a conversation with a historical figure. This is precisely what I mean when I state that time itself forms a fundamental obstruction to an interstellar civilization. The issue isn't that we lack the right kind of engines. The issue is that the laws of physics are communicating something very specific about the nature of our universe. They are stating that you can have locality, or you can have connectivity, but preserving both across the vastness of interstellar space is prohibitively difficult. Now, you might wonder, well, what if there are aliens who have overcome this hurdle? What if they've discovered a workaround? And to that, I would say, it's possible. Perhaps there's a layer of physics we have yet to discover. Maybe a method exists to circumvent these constraints that is currently beyond our wildest dreams. I would be thrilled to be proven wrong on this point, but here is the crux of the matter. We have zero evidence to support that idea. And in science, we cannot base our conclusions on the assumption that something exists simply because we cannot disprove it. We must proceed based on our current knowledge. And our current knowledge indicates that Einstein's relativity, as far as we can determine, is accurate. The speed of light is a constant, time dilation is a fact, and these realities make interstellar travel intrinsically and fundamentally arduous. This is why I often tell people, if you are searching for aliens, do not anticipate that they have paid us a visit. This is not because they do not exist, but because the universe is far larger and more isolating than our intuition leads us to believe. The enormous distances, when coupled with the relativistic consequences of high-speed travel, mean that interactions between civilizations would be incredibly infrequent and unbelievably slow. You would not have a Star Trek-like scenario with starships darting back and forth between solar systems. You would instead have isolated pockets of civilization, each aware of the others only through signals that take decades, if not centuries, to cross the void. And here's perhaps the most compelling part. This same restriction applies to any civilization that attempts to explore. Let's assume the aliens are unimaginably advanced. They've mastered the technology to build ships that can cruise at 90% of the speed of light for indefinite periods. They have overcome all the engineering hurdles. They still cannot bypass the fundamental constraint imposed by time dilation. If they wish to explore the galaxy and eventually return to their home world, they are faced with a dilemma. They can either traverse the galaxy slowly, a journey of thousands of years, aging at a rate similar to those at home, or they can move swiftly, aging very little, but in doing so, become completely disconnected from their point of origin. They cannot sustain a central base of operations and an expanding exploratory network at the same time, at least not in any meaningful way. Some might propose a situation where aliens have transitioned to a post-biological state. They have transferred their consciousness into machines. They no longer age. They can wait for eternity. Even for such beings, a problem persists. The light speed limitation means that causality itself becomes an issue. You cannot maintain a real-time chain of command. You cannot coordinate actions across interstellar distances. Each independent colony effectively becomes sovereign. They may have originated from the same civilization, but over time, they diverge. They evolve distinct cultures, different goals, different philosophies. It is almost as if the universe itself is structured to inhibit civilizations from expanding endlessly. I find this to be a profound insight. It suggests why the Fermi paradox might have a straightforward solution. Why don't we see aliens all around us? Why haven't they colonized the galaxy? Because the galaxy is so vast and the rules of physics are so restrictive that any civilization is essentially confined to its own local area. They cannot expand much further than a few dozen light years without severing ties with their home. They cannot maintain a galactic empire, and isolated outposts of civilization separated by light years and decades of communication lag will simply not have significant interaction with one another. Now, what does this mean for us? Well, we are here on Earth, facing the exact same predicament. If we were to dispatch a probe to another star system, we would have to come to terms with the fact that it would be entirely on its own. We could not control it. We could not assist it if it encountered a problem. It could transmit data back to us, but only after years or decades of travel. And if we were to send humans to another star, the challenge is even greater. Even in the most optimistic scenarios, where we somehow invent the technology to accelerate to 50 or 60% of the speed of light that is likely 1,000 years away, if it's possible at all, we would be contemplating journeys of decades or centuries. The crew on board would depart from Earth and arrive at another world where decades or centuries had passed for everyone they left behind. A return trip would be impractical. Sustaining contact would be impossible. They would be the ultimate colonists, utterly detached from their home planet. This is the rationale behind some scientists speculating about generation ships vessels where people would live their entire lives and their descendants, generations later, would be the ones to finally reach another star. You would have a complete society on board the ship, isolated for centuries, knowing that Earth was generations in their past. It is a possibility. It is consistent with the laws of physics, but it is also deeply isolating. It is the kind of solitude that would profoundly influence any culture that undertook such a journey. So when I ponder this question, why are there no aliens here? I think about these limitations. I consider the fact that the universe, while vast and likely teeming with life, is organized in such a manner that civilizations are essentially quarantined from one another. Each is confined to its own reference frame, navigating through space and time in its own bubble, unable to easily bridge the gap to connect with distant others. The speed of light is this ultimate barrier that can be approached but never exceeded. And time, that phenomenon we all perceive as flowing uniformly for everyone, is in fact malleable. Its pace shifts based on your speed. The universe, in a sense, has structured itself so that advanced civilizations would not be constantly bumping into each other. They would be isolated, separated by light years and communication delays and relativistic phenomena. And any civilization that attempted to expand too hastily, moving at high speeds through space, would find itself severed from its origin, unable to maintain a connection with where it came from. It's an inherent isolation mechanism. It's not something that was intentionally created, but it exists nonetheless, written into the very laws of physics. This is the dose of reality. This is why aliens are stranded in time. Not because they cannot build superior spacecraft, not because they lack the intelligence, but because the universe itself, the fundamental principles that dictate space-time, have arranged things so that rapid travel across interstellar distances inevitably leads to temporal separation. You cannot have both. You cannot quickly journey to other star systems and stay connected with your home. The choice is embedded in the equations, and I find a certain beauty in that, actually. I find it beautiful that the universe has these intrinsic limitations. It suggests that if other civilizations do exist out there, they are not going to appear suddenly and take over Earth. The physics simply won't permit it. They would either have to travel slowly or they would have to embrace isolation. And when faced with those constraints, the galaxy likely appears much more barren than our intuition would lead us to believe. Each pocket of intelligence is separated from the others by time and distance in ways that make contact challenging, rare, and protracted. So, that is what I am getting at when I say that aliens are stuck in time. They aren't held captive in some extraterrestrial sci-fi prison. They are bound by the laws of physics themselves. They are restricted by relativity. And if they are attempting to explore or expand, they must accept that expansion equates to isolation. They must accept that time will not behave for them as it does for those back home. They must accept that they are, in a very real way, moving through time and space into a future that their home world cannot access for years, or decades, or centuries. The universe is vast, it is magnificent, and it is structured in a way that keeps civilizations more apart than it brings them together. And grasping that, understanding time dilation, understanding relativity, understanding these fundamental constraints, provides us with a much more accurate depiction of what the cosmos is truly like, as opposed to what our imaginations might wish it to be. That is the interstellar truth.